Hello my dear students, welcome back to our channel. So we were discussing probability. If you are watching this channel for first time, please do subscribe to our channel. Okay, we can go to the video. We know how to find probability of an event. If E is an event, then probability of E is equal to sigma P of Wi. Wi belongs to E. And if the outcomes are equally likely, this will become m by n, where m is the number of elements in E and n is the number of elements in S. This we have discussed. For equally likely outcomes, P of Wi will be 1 by n for all I. So if E has m elements, then sigma P of Wi is equal to, if it has m elements, 1 by n plus 1 by n plus etc. m times, that is m by n. That is number of elements in E by total number of elements in S. This we know. We can see how to find probability of the event A or B. Consider the experiment of tossing a coin thrice. Then what is the sample space? S is equal to, we know, H, 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 T, H, T, H, H, T, 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 H, H, T, H, T, 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 H, T, T, T. 8 elements. Let A be the event, H, H, T, H, T, H, T, H, H. And B, H, T, H, T, H, 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 H. Then what is A union B? A union B is equal to elements of A or elements of B. That is HHT, HTH, HTH common here also, THH, THH is here also, and HHH. That is HHT, HTH, THH, HTH and THH written HHH. Then what is P of A union B here? P of A union B is equal to, by definition, sigma P of Wi. Wi is HHT, HTH like that. So this is P of HHT plus P of HTH plus etc. plus P of HHH. So here 4 elements. If probability of each event is given, we can substitute. Or if the outcomes are equally likely, then each probability will be 1 by 8. Here S has 8 elements. So each element has probability 1 by 8. So this will be 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8. That is 4 by 8, which is equal to 1 by 2. And here P of A is equal to 3 elements, 3 by 8. And P of B is equal to also 3 by 8. Is P of A union B equal to P of A plus P of B? See, P of A plus P of B is equal to 3 by 8 plus 3 by 8, that is 6 by 8, that is equal to 3 by 4. That is 0.75 here probability, but here is 0.5. That is not equal to P of A union B. But is there any relation between P of A union B and P of A plus P of B? We can see. Here A and B has these 2 elements common, HTH and THH common. So while calculating P of A plus P of B, the probability of these elements are counted twice. Here also we counted, and P of B also we are counted. So these 2 elements counted twice. This is nothing but A intersection B, elements of A intersection B. So we can subtract the probability of A intersection B from P of A plus P of B to get P of A union B. So we can say P of A union B is equal to P of A plus P of B minus P of A intersection B. So this is the formula to find probability of A union B. We can see how to get this formula. Probability of the event A or B. A or B is nothing but the event A union B. So we can say probability of A or B or A union B is equal to, by definition of probability, we can say this is sigma P of Wi. Wi belongs to the event A union B. We can see A union B. Let S be the sample space and A be the set and B the set. S, A, B. What is A union B? This union this. That is, we can say this portion union this portion union this portion. What is the red portion here? Red portion is from A we are subtracting the portion of B. This is A, we are subtracting the portion of B. So we can say A union B is equal to A minus B union this portion union green portion union this blue portion. Green portion is nothing but the portion common to A and B, that is A intersection B. A intersection B union, and this blue portion is nothing but from B we are subtracting this portion of A, that is B minus A. Red portion is A minus B, green portion is A intersection B, and this blue portion is B minus A. So A union B, we can say union of these three portions. So we can say P of A union B is equal to sigma P of Wi. Wi belongs to A union B. That is the union of these three sets. Wi belongs to A minus B union A intersection B union B minus A. See here, these three sets are mutually exclusive also. That is, this red portion has no intersection with these sets. Like that, these three sets are mutually exclusive. So by definition of probability, we know P of A union B is equal to P of A plus B if A and B are mutually exclusive. So we can write P of A union B is equal to sigma P of Wi. Wi belongs to A union B, but A union B is this set and all these are mutually exclusive. So we can write sigma P of Wi. Wi belongs to A minus B plus sigma P of Wi. Wi belongs to A intersection B plus sigma P of Wi. Wi belongs to B minus A. So consider this equation as 1. Like that, we can write P of A plus P of B also. P of A plus P of B is equal to sigma P of Wi. Wi belongs to P of A is sigma P of Wi. Wi belongs to A plus P of B is sigma P of Wi. Wi belongs to B. But we know A is equal to this A minus B red portion union this green portion A intersection B. You can say A is equal to A minus B union A intersection B. Like that, B is equal to B is this set, that is blue union green, that is B minus A union A intersection B. We can substitute instead. So P of A plus P of B is equal to sigma P of Wi. Wi belongs to A minus B union A intersection B. A is nothing but A minus B union A intersection B. And A minus B and A intersection B are mutually exclusive, no common elements. So their probability is nothing but sum of their probabilities. So Wi belongs to A minus B plus sigma P of Wi. Wi belongs to A intersection B. We have written this portion also only. Sigma P of Wi. Wi belongs to A is nothing but sigma P of Wi. Wi belongs to A minus B plus sigma P of Wi. Wi belongs to A intersection B. Plus this portion is sigma P of Wi. Wi belongs to B. B is this set. So Wi belongs to B minus A plus this is mutually exclusive. So we can write the probability of this union is sum of their probabilities since mutually exclusive. Sigma P of Wi belongs to A intersection B. This is equal to sigma P of Wi belongs to A minus B plus sigma P of Wi belongs to A intersection B plus sigma P of Wi belongs to B minus A. This is nothing but P of A union B. P of A union B plus a remaining sigma P of Wi belongs to A intersection B. That is nothing but P of A intersection B. So we have get P of A plus P of B is equal to P of A union B plus P of A intersection B. So we can write P of A union B is equal to P of A plus P of B minus P of A intersection B. That is P of A union B or P of A or B is equal to P of A plus P of B minus P of A intersection B. So this is how we get this formula. We can see another method to derive this formula, simple method. We can draw the diagram again. Let S be the sample space, A be the set and B the set. A, B, S. A union B, we can say in another way also. A union this portion, this green portion. This is nothing but A union B is equal to red portion is A union blue portion is B minus A. And also A and B minus A are mutually exclusive, no common elements. So we can write P of A union B is equal to P of A union B minus A. Instead of A union B, A union B minus A. And A and B minus A are mutually exclusive. So by axiom 3, their probability is nothing but sum of their probabilities. That is P of A plus P of B minus A. Why? Because mutually exclusive. And also what is B here? Set to B is equal to A intersection B union this blue portion B minus A. That is A intersection B union B minus A. Also these two sets are mutually exclusive. So we can write P of B is equal to P of A intersection B union B minus A. Since this is mutually exclusive, by axiom 3 we can write P of A intersection B plus P of B minus A. This is also because mutually exclusive. Consider this equation as 1 and this one 2. Then 1 minus 2. What is 1 minus 2? P of A union B minus P of B is equal to P of A minus P of A intersection B plus P of B minus A minus P of B minus A get cancelled. So P of A minus P of A intersection B. That is P of A union B is equal to P of A plus P of B minus P of A intersection B. Simple, right? Suppose A and B are disjoint sets. Then what will be P of A union B? If A and B are mutually exclusive or they are disjoint, then we say A intersection B is equal to empty. Then P of A intersection B is equal to P of phi is equal to 0. So P of A union B is equal to P of A plus P of B. If A and B are mutually exclusive events, we can say P of A union B equal to P of A plus P of B. Next, we can see the probability of the event not A. Probability of the event not A. Consider the experiment of drawing a card from a deck of 10 cards numbered from 1 to n. Then S is equal to 1, 2, etc. 10. Consider the event A is equal to 2, 4, 6, 8. If probability of each single outcomes are not given, then we are taking the outcomes are equally likely. So here we can take the outcomes are equally likely. Then probability of each outcomes will be here total 10 elements, then 1 by 10. That is probability of 1 is equal to 1 by 10. Probability of set 2 is equal to 1 by 10, like that. Then what is P of A? P of A is equal to probability of singleton set at 2. Instead we can write probability of 2 plus probability of 4 plus probability of 6 plus probability of 8. That is equal to 1 by 10 plus 1 by 10 plus 1 by 10 plus 1 by 10. That is 4 by 10. That is equal to 2 by 5. Then what is the event not A here? Not A or A dash is equal to the elements in S that is not in A. That is set 1, 3, 5, 7, 9, 10. Then what is P of A dash here? Here A dash has 6 elements. So P of A dash is equal to 6 by 10. That is equal to 3 by 5. Is there any relation between P of A and a P of A dash? Here see 3 by 5 is nothing but 1 minus 2 by 5. That is 1 minus P of A. How we derive this formula? This is a simple. We know A and A dash are mutually exclusive events. That is their intersection is empty. And also they are exhaustive events. That is their union is nothing but the sample set itself. A union A dash is equal to S. You can say A intersection A dash is equal to 5 and A union A dash is equal to S. That is mutually exclusive and exhaustive events. From the second one we can write P of A union A dash is equal to P of S. We know P of S is 1. And since A and A dash are mutually exclusive, we can write P of A union A dash is nothing but P of A plus P of A dash is equal to P of S is 1. So P of A dash is equal to 1 minus P of A. This derivation is simple, right? P of S is equal to 1 from axiom 2 of the definition of probability. And this one is nothing but the axiom 3 of probability. That is P of A union B is equal to P of A plus P of B if A and B are mutually exclusive. So this is all about probability of A union B or A or B and the probability of not A. We can see some example, then it will be more clear. We can see the solved examples or problems in the next video. Keep watching. If you find this video useful, please like, share, comment and subscribe to our channel. Thank you for watching. Thank you.